Try it right now. Take your own fingers and dig them into your ribs, your neck, the arch of your foot, wherever you know you're most ticklish. Really go for it, the same way someone else would to make you shriek. Nothing happens. Maybe a faint pressure, a vague awareness of your own hand, but the squirming, the helpless laughing, the reflex to twist away, none of it fires. Now picture someone else running their fingers over that exact same spot, at that exact same speed, with that exact same pressure. You already flinched a little just imagining it. Same fingers, same spot, same pressure. The only thing that changed between the version that does nothing and the version that would leave you gasping is who was in control of the hand. And that gap, that strange dead zone around your own touch, is not a quirk or a party trick. It's a visible edge of one of the most important calculations your brain runs every single second you're awake. A calculation so good at its job that you've never once noticed it working. This is an old question, older than neuroscience, older than psychology as a field at all. Aristotle wrote about it more than 2,000 years ago, genuinely puzzled that a person cannot tickle themselves the way another person can. Charles Darwin circled the same problem and landed on a clue that turns out to be central. For the strong, laughter-producing kind of tickle to work, he noted, the precise spot being touched has to be uncertain. You have to not quite know where it's coming next. Hold that thought, because it's the whole answer in miniature. Start with the fact that there are actually two different things we lump under the word tickle. The first is the light, feathery kind, a single hair dragged across your forearm, an insect-crawling sensation that makes you want to brush the spot. Psychologists gave it the name nismesis. The second is the intense, overwhelming kind, the ribs and armpits assault that produces uncontrollable laughter and thrashing. That one is called gargalesis, and it is a genuinely strange reflex because the laughter it produces is not happiness. People being tickled hard will laugh and beg you to stop in the same breath. And crucially, gargalesis is the kind you almost cannot produce on yourself, no matter how hard you try. To understand why, you have to look at what your brain is doing every time you move any part of your body. When you reach out to touch something, your motor cortex sends a command down to your muscles. But it does something else at the same time, something you have no awareness of. It sends a copy of that command, an internal duplicate scientists call an efference copy, sideways to another part of the brain. Your cerebellum takes that copy and uses it to build a prediction. Given that this exact movement is about to happen, here is precisely what it should feel like, on which patch of skin, with what timing and pressure. It runs this forecast a fraction of a second before the actual touch lands. Then the real sensation arrives, travels up from your skin, and your brain compares it against the prediction it already made. When the two match, which they almost always do for your own movements, the brain does something remarkable. It turns the sensation down. It actively subtracts the predicted feeling, dampening it before it ever reaches full awareness. This is called sensory attenuation, and it's the reason your own touch feels muffled and boring compared to the identical touch from someone else. You are not feeling the raw sensation. You are feeling the raw sensation minus what your brain already knew was coming. The person who nailed this down experimentally is a neuroscientist named Sarah-Jayne Blakemore, working in London in the late 1990s alongside Daniel Wolpert and Frith. They put people in a brain scanner and had them experience the same soft touch on the palm in two ways, sometimes delivered by the experimenter, sometimes self-delivered by the person's own hand movement. The brain scans were clear. Self-produced touch generated markedly less activity in the somatosensory cortex, the region that processes touch, and less in a part of the cerebellum. The brain was measurably muting a sensation simply because it had generated it. But the truly clever experiment came next because they built a machine. They set up a robotic contraption where you moved one lever with your hand, and that movement drove a second arm that delivered a soft, foam touch to your other palm. So you were, in effect, tickling yourself, but through a robot in the middle. And here's the switch they could flip. They could introduce a delay between your movement and the touch, or they could rotate the direction so the touch arrived at a slightly different angle than your motion. When the robot delivered the touch instantly and faithfully, matching your movement, it felt dull and unticklish, exactly like tickling yourself normally. But when they added a delay of even a fifth of a second or twisted the trajectory, The ticklishness came flooding back. The very same self-generated movement suddenly felt like being tickled by someone else. That is the entire mechanism laid bare. The moment the incoming sensation stopped matching the brain's prediction, the attenuation switched off, and your nervous system reclassified the touch from me, expected, ignore, to not me, unexpected, alert. Your ticklishness was never about the touch itself. It was about whether the touch was predictable, which raises the real question. Why would a brain be built to work like this at all? Why go to all the trouble of predicting and canceling the feeling of your own body? The answer is that your skin is under a constant, relentless barrage of self-generated sensation that means absolutely nothing. Your clothes dragging on you as you walk, your own arm brushing your side, your tongue sitting against your teeth, your fingers touching each other. If you consciously felt every one of those at full volume, you would be drowning in noise, unable to pick out the one signal that actually matters. Something touching you that you did not put there. A leaf, a spider, another creature's hand, a predator's breath. Sensory attenuation is how the brain clears away the predictable static of your own body so that the genuinely external, genuinely unexpected touch can jump out and grab your full attention instantly. And notice where you're most ticklish. The ribs, the neck, the soft underside of the arm, the feet, the belly. These are not random. They are among the most vulnerable, least protected regions on the body, the places where a threat would do the most damage and where you have the least armor. A hypersensitive alarm that fires the instant something unexpected touches those exact zones and triggers an immediate reflex to twist, guard, and pull away is precisely the kind of defensive wiring you'd want. Some researchers think the laughter and the play of tickling is how that defensive circuitry gets built and rehearsed safely between parent and child, between siblings, learning to protect the body's soft spots through a game. Once you see the mechanism, you start noticing it everywhere. It's why you can carry a full cup of coffee across a room without the sloshing at your own fingertips startling you, while the same jolt from someone bumping the cup makes you jump. It's why you can't make yourself flinch on command, and why a shove you brace for lands softer than one you don't. In every case, the brain is doing the identical thing, forecasting the sensory result of a known action and quietly turning it down, spending its limited attention only on the parts of the world it couldn't predict. Tickling is just the most dramatic, most obvious demonstration of a filter that is running silently underneath everything else you feel. But the deepest part of all this isn't really about touch at all. Sit with what the brain is actually computing every waking moment, a running, real-time distinction between sensations you caused and sensations the world caused, between me and not me. That boundary sounds obvious, almost too basic to need a mechanism until you meet the cases where it breaks. Blakemore and her colleagues went on to study people with schizophrenia, particularly those who experience what are called passivity symptoms, the feeling that one's own movements or thoughts are being controlled by an outside force, and those who hear voices. And they found something striking. Many of those patients can tickle themselves. The normal attenuation, the muting of self-produced sensation, doesn't happen properly in their brains. Think about what that implies. If the system that tags your own actions as yours starts misfiring, then your own movements can start to feel like they came from outside you. Your own inner voice, which is in a sense a self-generated signal your brain should be predicting and attenuating, can start to feel like an external voice, a stranger speaking inside your head. The same prediction machinery that quietly cancels the tickle of your own fingers may be part of what gives every healthy person the unshakable sense that their thoughts and actions belong to them. When it fails, the border between self and world gets thin, and that is one of the leading ideas about where certain hallucinations come from. The inability to tickle yourself, in other words, is a tiny, harmless readout of a system whose full job is keeping you anchored inside your own body. So there is something almost reassuring in that dead zone around your own hand. It isn't a limitation. It's evidence of a brain so relentlessly good at predicting the consequences of your own movements that it deletes them before you can even register them, clearing the stage for whatever you didn't see coming. The tickle you can't give yourself is the exact same tickle that keeps you from being overwhelmed by the constant hum of your own existence. And the exact same signal that, in a healthy brain, quietly insists, this is me, this is my hand, these are my thoughts, and I am the one in here doing all of it. So go ahead and try again. Dig your fingers into your own ribs, right where you know you're most helpless when someone else does it. Still nothing. Not because you're not ticklish, but because your brain saw your hand coming a fraction of a second before it arrived, ran the math, and quietly erased the surprise before you ever had the chance to feel it.